Hi everyone, this is Puya. So in this video, we're going to discuss basics of a mathematical problem called Hanoi Tower or Tower of Hanoi. This is a mathematical problem that's rooted in an ancient problem. We have three rods. Let me take all the discs out. We have three rods and n discs, and if all the discs are placed in one rod, let's call it the source rod, we want to move all these n discs from one rod to another rod. So let's call this one source rod, this one is destination, and this is auxiliary. There are two main rules in the Hanoi Tower problem. Is that the first one is that you can only move one disk at a time, and the other rule is that you can only place a smaller disk on top of a larger disk. So no large disk can go on top of a smaller disk. And we want to know how we can solve this using a computer program. So we're going to see two different approaches to solve this problem. The first one is a recursive solution. The second one is a non-recursive solution. But before we go to the C++ program and solve it using a computer program, we want to see how we can solve this mathematically. So first of all, let's look at the recursive solution. So first of all, if you only have one disk on a rod, this is pretty straightforward. If you only have one disk, let me make sure that you can see this. Yes, if you only have one disk, then it's pretty straightforward. You only need to have one movement from source to destination. That's it. That's pretty straightforward. Now, so we know how to move one disk from one source, from one rod to another rod. If we add another one, what we need to do is basically move the top disk to the auxiliary rod, the source one to the destination rod, and then the auxiliary one to the destination rod. That's solved. Right, so now we know how to move two disks. We already know how to move two disks from source to destination. If I add one more, okay, now we have three disks. We already know how to move two disks using three moves from one rod to another rod. Okay, so I already know how to move these two disks. Let's assume that the third one doesn't exist. I already know how to move these two disks from one rod to another rod, right? So let's just move them like to this auxiliary rod. Of course, I'm moving them all at the same time, both of them at the same time. It's gonna take three moves to do that, but I'm just gonna assume that I do those three moves and then move all of them to the auxiliary rod. If I do that, then the problem is pretty straightforward now. I just need to move this last rod from source to destination. And then again, the problem is reduced to moving two disks from one rod to another rod. So what I need to do is just again, using three different moves, move these two disks here. So if I have three disks, the problem is going to be reduced to, let me actually do this. If I want to move 2 disks from source to destination, I move 1 from source to auxiliary, then from source to destination, and from auxiliary to destination. If I only had 2, let's just like go back to the 2 disks. If I only have 2 disks, I only need to move the top one to the auxiliary, from source to destination, and from auxiliary to destination, right? If I have 3 disks, then the problem, it's gonna be moving 2 disks from auxiliary, from source to auxiliary, right? And I already know how to do this because you already know how to move 2 disks from one pole to another pole, right? It's gonna take 3 moves, these 3 moves, but this time I wanna move them from source to auxiliary, right? So like I'm gonna, basically it's gonna be like this, 1, 2, 3, right? Now I'm just gonna move this one from source to destination, and again the problem, it's gonna be, so like move 2 disks from source to auxiliary plus 1 last disk from source to destination, and then the problem, it's gonna be moving 2 disks from auxiliary to destination. Okay, I'm gonna do this one more time. Now let's see how this can expand. Now if we have 4 disks, I already know how to move 3 disks from one pole to another pole, right? It's gonna take multiple moves, but I know exactly how it's supposed to be done. So this time I'm gonna move from source, these 3, the first 3, I'm gonna move them from the source to auxiliary. It is possible, right? I know how to do that. I'm doing it all at the same time. It's gonna take multiple moves because we can only move 1 disk at a time. But I already know the combination of the moves that's needed to move 3 disks from one rod to another rod. So this is possible. And then I'm just gonna move the last disk here from source to destination. And then again, the problem, it's gonna be moving 3 disks from the auxiliary rod to the destination rod. So if I have 4 disks, what I need to do is moving 3 disks from source to auxiliary, and then move the last disk from source to destination, and move 3 disks from auxiliary to destination. Can you guys see the whole whiteboard? Yes, you can. Okay, so, and this can go on, right? So you basically see that if I know how to move n disks from one rod to another rod, I know how to do n plus 1 disks from one rod to another rod. Or if I know how to move n minus 1 disk from one rod to another rod, I know how to do n disks from one rod to another rod. So let's look at this recursively. Let's look at this, how we can solve this recursively, right? So let's assume that we have n rods. Sorry, n disks. N disks, 3 rods. Okay, so if we have n disks, what we need to do first, we need to move n minus 1 disks, move n minus 1 disks from source to auxiliary. right? So I'm just like redefining the problem as solving the smaller version of the same problem. So if I want to move n disks from one rod to another, I say like, okay, let's first move the first n minus 1 disks from source to auxiliary. If I can do that in a series of, in a combination of moves, then the second step would be moving one disk, which is the last disk, from source to destination. And again, it's gonna be, the last step would be moving n minus 1 disks from auxiliary to destination. Okay, so this looks exactly like a recursive problem, right? So this is exactly what we can implement using a computer program, because now we are redefining a problem of size 1 and finding its solution based on solving a problem of size n minus 1. And we're calling this function, we're calling this solution twice. One time to move n minus 1 disk from source to auxiliary, and then after moving the last disk from source to destination, moving the n minus 1 disks that are on the auxiliary part from auxiliary rod to the destination rod. So this can go on like this. We can just like keep reducing the number of disks until we get to a base case. What is our base case? The base case is gonna be, just gonna write it down here. The base case, or the stopping criteria, would be if n is equal 1, we already know how to solve this problem. We only need to do one move from source to destination. That's it. Okay, so if we want to move like n disks from this rod to this rod, we have to keep doing these 3 steps, right? We have to keep reducing the number of n so that we approach n equal to 1. As soon as we get n equal to 1, we know how to solve this, right? We know that we only have one move and like moving that disk from source to destination. So this is a recursive problem. We can just easily implement it using a function. How can this be implemented? So I'm just gonna write a function for that. So let's just write it as a void function, void recursive Tower of Hanoi, right? Okay, so integer n, let's say character source, character auxiliary, and character destination. Okay, so if I want to move n disks from source to destination, what I need to do, I just need to call the same function with n minus 1 disks, right, from the same source, but this time I want to move n minus 1 disks from source to auxiliary. So my destination for this move, it's going to be the auxiliary rod. I want to move these n minus 1 disks from source to auxiliary, right? and I'm just going to use the destination rod as the auxiliary rod in this move. Okay, then the last move, I'm just going to display it. It's going to be let's say move one disk from source to destination. And actually, like, instead of this, we can actually put put n, because this is going to be the nth disk, right? This is going to be the nth disk. This is the last disk that we have to move. So I actually could write this like this. Like something like that. Anyways, this is not perfect, but this basically shows that first we need to move the first n-1 disk from source to auxiliary using the help of the destination rod, right? Move the last disk from source to destination, and then again call the same function. Move the n-1 disk that we placed on the auxiliary rod. This time we have to move it from auxiliary rod to the destination rod. And this time we're going to use the source rod as the auxiliary rod in this case, right? So this is basically the recursive part of the function, right? But we need to have a base case because we are decrementing the n at every step, right? So we need to stop at one point, right? So we just say that if n is equal 1, right? If you only have one disk, then we just basically have to cout move from source to destination. Okay, this is not perfect. I'm not writing the the message perfectly, but I just wanted to show you the schematic of the different commands that we need to have for this recursive function. You can see that it's pretty straightforward. This complicated problem, we can solve it recursively very easily, right? We don't need to know about the number of steps that it takes. We don't need to know exactly like which moves we have to do for every number of n. We just implement this using a recursive function. It's not going to be a very time efficient method. As mentioned, like, we're going to be calling this function many times, right? So we're going to have a huge excuse me, a huge call stack. However, for the programmer, it's going to be very easy to write this. He doesn't know, the programmer, he or she doesn't need to have much information about the problem solution itself, right? You just you call the function, you let the compiler, you let the computer program to take care of this. So this is how we can easily solve the Hanoi Tower problem or Tower of Hanoi problem using a recursive function. It's pretty straightforward. It's one of the good examples of recursion. Okay, I hope this makes sense. Now let's look at the same problem and see how we can implement this non-recursively. If we want to implement this non-recursively, we need to have some information. We need to have like some mathematical analysis for this problem. So we already, let's just have maybe this many. We already saw that if, let me define this function as the number of moves. number of moves needed, to move n disks from source to destination. Okay, and we already saw that if we want to do this, we have to move n-1 disks from one rod to another rod, right? And then move the last disk from source to this destination, and then move again n-1 disks from the auxiliary rod to the destination rod. So this is basically 2 times f of n-1 plus 1. Let's look at this. If n is equal to 1, we only need 1 move. If n is equal to 2, we need 2 times 1 plus 1. We need 3 moves. If n is equal to 3, we need 2 times 3 plus 1, 7 moves. N equal to 4, this is going to be 2 times 7 plus 1, 15. And this can go on. Now, based on what let me do one more. N equal to 5. This is going to be 2 times 15, 30 plus 1, 31. And this can go on. Okay. Now, if I want you to find an explicit formula for f of n, can you see like what's happening here based on n? Can you just like find a formula that gives us the number of moves needed to move n disks from one rod to another rod? Look at this. I don't want it to be recursive or an implicit solution. I just want to know like something exactly in terms of n. Is it possible? So if you think about this, this is actually 2 to power 1 minus 1. This is 2 to power 2 minus 1. This is 2 to power 3 minus 1. This is 2 to power 4 minus 1. This is 2 to power 5 minus 1. And it's going to be exactly like this for the rest of them. So you can think of the f of n as 2 to power n minus 1. These are the moves, these are the number of moves that is needed to move n disks from source to destination, right? So we know exactly how many moves are needed. So if somebody asks you what is the big O notation of this problem, what is the order of this problem in terms of time complexity, it's going to be order of 2 to power n. Okay, so now we know exactly how many moves are needed to move the disks from one rod to another rod. Okay, now if we want to solve this non-recursively and iteratively, we need to also like find like the exact moves. What are the moves needed? Let me put 3 rods here. Okay, so we know that if we have 3 disks, if we have 3 disks, we need to have 1, 2, 3, 4, 5, 6, 7 moves. All right, because 2 to power 3 is 8 minus 1, it's going to be 7. Okay, now let's look at the moves that are needed here. We already did this, so let's do this. The first move that I need to do is moving this purple disks purple disk from source to the destination. So first it's going to be source to destination. The second one, it's going to be from source to auxiliary. The last one, the third move, it's going to be from, I jumped ahead, it's from the destination to auxiliary. And always remember that when we want to move like a disk between two rods, like if I say that like move from auxiliary to destination, move like between auxiliary and destination, there is only one legal move, right? If I say that like we need to move a disk between these two rods, auxiliary and destination, there is only one legal move. Only like we can move this one from here to here. We can't move this one from auxiliary to destination. Okay, so here this is what we did. The fourth one, it's going to be from source to destination. Okay, what's the next one? It's moving between auxiliary and source. Right? The next one is going to be moving between auxiliary and destination. Can you guys see the whole whiteboard? Yes. Okay. And auxiliary and destination. And the last move would be moving between source and destination. Okay. Now let's look at these moves. I'm just gonna divide them into 3 moves. So you see that the first one is a move between source and destination. The second one is between source and auxiliary. The third one is between destination and auxiliary. Right? And look at what's gonna happen between 4, 5, 6 and compare it with between 1, 2, 3. Again, we're gonna have a move between source and destination. We're gonna have a move between auxiliary and source. It's gonna be the reverse of what we did before, but you remember that when you want to move a disk between 2 rods, there is only one legal move. So we're gonna move between auxiliary and source. We're gonna move between auxiliary and destination. And again, we're gonna move between source and destination. These two are the same. So we have to move between source and destination. These two are the same. We have to move between source and auxiliary, right? Although this is the reverse of that, but we know that like if we just like have to check which one is bigger. Which like on like the toppest disk on auxiliary and destination and source, we have to check which one is bigger so we can figure out if it's between source to auxiliary or between auxiliary to source. But we know that the one disk that we have to move, it's gonna be moving from either source to auxiliary or auxiliary to source. And the same thing happens here. And again, the same thing just gonna be happening here. Okay, so in this situation, it's pretty straightforward. And if I add like 2 more disks here, you're gonna see that exactly the same thing it's gonna follow, right? So we basically say that like, okay, we know exactly these many moves that we have to have, right? Let me call actually this one K. This is the number, oh, actually it doesn't matter. N. Okay, right? So I know that I need to have a loop that goes from, let's say 1 to 2 n minus 1. These many moves are needed. Okay. And you see that like the moves that we have, it's going to repeat itself every 3 moves. So I can say that if I mod 3 is equal to 1, we need to move between source and destination. We need to have a legal move between source and destination. If I mod 3 is equal to 2, we need to have a legal move between source and auxiliary. If I mod 3 is equal to 0, we need to have a legal move between destination and auxiliary. Sometimes it's going to be from destination to auxiliary, sometimes it's going to be between auxiliary and destination. We have to check which one is going to be legal, right? So then it's going to be pretty straightforward to program this iteratively or non-recursively. We can have 3 different stacks and just move the disks from one stack to another one exactly like this, right? So this is going to be the solution that we need to have for it's going to be the same solution that we need to have for an Hanoi of tower non-recursively. However, there is one problem here, right? So this is okay. Let me remove this, and let me just like do four disks. That's going to be a lot of moves. Let's just like do 2 disks. So I need that, I know that like if we have 2 disks, we're gonna have only 3 moves. And I wanna see if it's gonna be following exactly the same thing, right? Let's look at this one. Like if I have 2 disks, I need to, the first move, it's gonna be between source and auxiliary. The next one, it's gonna be between source and destination. And the next one, it's going to be between auxiliary and destination, right? If I add 2 more here, you're going to see that the same pattern is going to repeat. So, and these 2 are different now. Here, like I had in the first move, I had to move from source to destination, then source to auxiliary, then destination to auxiliary. But if I have 2 disks, it's going to be source to auxiliary, source to destination, auxiliary to destination. So you see that if n is odd or n is even, we have different rules. So that's another thing that we have to check. If n is odd, we're gonna do this series of moves, right? If n is even, it's gonna be a little bit different. But the only difference you see that here is that we only need to change the auxiliary and destination. That's the only thing that's gonna be different between the case when n is odd and n is even. Right, so like you can see that like here, instead of moving from source to destination, we are moving between source and auxiliary. Here between source and auxiliary, here source and destination. So what we can do is basically check if n is odd. If n is odd, we need to do this, right? If n is even, again, it's gonna be like if I mod 3 is equal 1, move between source and auxiliary. If I mod 3 equal 2, move between source and destination. If I mod 3 is equal 0, move between auxiliary and destination. Okay, and then it's gonna repeat itself, right? So like that's pretty straightforward now. Now we know how to solve this. Let's actually like do this for 4 rods. I'm gonna follow this, right? So it says that, okay, so we're gonna count, right? The first move is between source to auxiliary. We're gonna see like if this method is gonna work for 4 disks, right? Source to auxiliary, then source to destination, then a move between auxiliary and destination. Which one is legal? This one, right? Then it's gonna come back here between source and auxiliary. So source to auxiliary, there is only one legal move. Between source and destination, right? Between source and destination. Can I move this one on top of here? No, I can't, right? So it's gonna be from destination to source. Let me do this like this so that it's not confusing. So it's a legal move, right? It might be between from source to destination or from destination to source. So in this case, it's going to be from destination to source. Then the next one is between auxiliary and destination again. So here, can I move from here to here? No, I can't, because this is larger than this one. So auxiliary and destination. Then it's gonna come back here between source and auxiliary. This is possible, right? You see, like we moved after 7 moves, we moved 3 disks from source to auxiliary, right? Now the 8th move, right? 8 mod 3 is equal to 2, right? So this is the case, right? So source to destination, auxiliary to destination, right? Auxiliary to destination. Can I move this one here? No. So I have to move this one here. Then it's gonna come back here between source and auxiliary. I don't have anything here to move to auxiliary, but I can move this one here, right? And then source to destination, right? So like this one cannot go on top of this, but this one can go on top of this one. Then between auxiliary and destination, it's gonna come back, source to auxiliary, source to destination, auxiliary to destination. This works perfectly fine. Let's see if we have 5 disks, how this one works. Now we have to follow this one, right? I'm just gonna do it very quickly. Source to destination, source to auxiliary, destination and auxiliary, again source to destination, source to auxiliary, destination to auxiliary, come back here, source to destination, source and auxiliary, destination and auxiliary, come back here, source, destination, source, auxiliary, destination, auxiliary, source, destination, source, auxiliary, destination, auxiliary, destination, auxiliary. We moved 4 disks from source to auxiliary, so it comes back here, source, destination, source, auxiliary, like there's nothing here, so like move this one here, destination, auxiliary, comes back here, source, destination, source, auxiliary, destination, auxiliary, source, destination, source, auxiliary, destination, auxiliary, source, destination, source, auxiliary, destination and auxiliary, comes back here, source to destination, source to auxiliary or source and auxiliary, destination, auxiliary, and finally this one. So we saw that if n is odd, we know that we're gonna have 2 to power n minus 1 moves, right? And we count the moves, right? So I is gonna go from 1 to 2n minus 1. If I mod 3 is equal to 1, like the first move, this move has to be the legal move between source and destination. If I mod 3 is equal to 2, the move has to be between source and auxiliary. If I mod 3 is equal to 0, the move has to be between this destination and auxiliary. And the same thing, it's going to apply if n is even. The only difference is that you just have to swap the auxiliary and the destination, right? Or you can rewrite the rules like differently. Like the first move, it's going to be between source and auxiliary, then source and destination, then auxiliary and destination. Okay, so this is how we can solve the problem Tower of Hanoi non-recursively. So in the next video, I'm gonna implement them and I'm gonna compare them. I'm gonna show you the solution for both of the methods done in C++. Thank you so much.